Alright guys, so I'm gonna start because otherwise I'm wasting everybody's public holiday and I'm pretty sure you guys will wanna go. Alright guys, I'm gonna start. Sorry, I'm staring at you sideways. I'm gonna start because otherwise I'm wasting everybody's Monday, everybody's public holiday, and I'm pretty sure you guys all want to get going and studying and all of these things. I'm going to keep the chat open on my second screen. So if there are any questions, just let me know. I'm going to keep my own camera muted purely because then it saves everybody a little bit of data. And then I'm going to use the visualizer. I've said to the guys who were in here a little bit earlier, I am recording this on OBS because Google Meets no longer allow us to record. Silly, but anyway. And then I will put it onto YouTube. I'm going to, just to try and get it out there as quick as possible, going to dump it onto YouTube as one big long video. And then what I'll do is I'll go back and snip it into topic by topic by topic and re-upload all of them. I won't delete the original one. Just like last time, I will email you the paper and my handwritten memo. Unlike last time, I won't do it cryptically. So yeah, guys, I've got the chat open here. If there are any issues, let me know. Questions, queries, comments. And then obviously there is the raise the hand function if you want to use that. I've made a lot of you guys co-hosts. I unfortunately cannot do the thing of keeping an eye on people that are coming in later and trying to also get you guys through this paper. I'm literally picking at random, so most of you guys who have names that start with letters earlier in the alphabet, you guys are getting that role and responsibility. Okay. So please, I'd really appreciate it if you guys could just keep half an eye on the waiting room, if there is anyone, so that we can have as many people in here as possible. Yeah, and then I think without further ado, let's have a look at this. I'm going to do it exactly like I did last time, going per topic. And please remember that we haven't done all of the chemistry, just like we haven't done all of the physics. So there are going to be bits and bobs that we're going to leave out, obviously. I've had a look just to double check the question paper. There is nothing in there about pH calculations, although it's a very easy calculation. There is no redox. I know some of you guys were worried about that. That's for the next section of chemistry where we do electrochemistry. What else? There is no ideal gases. You'll see in this question paper, the only part of gases that we do have is that it gives you the idea why molar gas volume isn't always 22,4. So that's the only reason we do ideal gases at all. So you guys can have a relax about that. There is a question in this question paper that I think is quite interesting. That is quite easy to master. It's a little bit of theory that I am going to delve into for pHs. Yeah, and then let's get going. So we're going to start with the organic nomenclature. So I'm going to start with the multiple choice questions for those. I thought some of these were horrific. I'm going to do all the multiple choice questions, whether it's nomenclature or physical properties, because they are a bit mix and match in the multiple choice. The organic chemistry questions are 1.1, 1.2, and 1.3. There we go. Alright, so the first question, to this day, I do not have a solid answer for you on what the answer is, but anyway. So the first question asks, how many van der Waals forces? So if you guys remember, we did London forces, which was forces between non-polar and non-polar, which is all your alkanes, alkenes, and alkynes, right? Because there's only a carbon and a hydrogen. Then we did dipole-dipole, And dipole kicks in the second there is something that is more electronegative, or like with the halides where you have those lone pair electrons and things like that, creating that space where there's more electrons, so there's a slight dipole there. For dipoles, we look at aldehydes, we look at ketones, and we look at our haloalkanes. Right, and so instantly you will see that there's a haloalkane, so we know we're dealing with dipole. And then we've got our last one, our strongest force, our hydrogen bonds, which we go for alcohols and carboxylic acids. And that's not what we're dealing with here. You have to have an oxygen in the mix here for you to have any chance of a hydrogen bond. Okay, so the answer, we've definitely got a dipole here. But what I just want to point out to you guys, and this is where the issues come in with answering this question, because between, I'm just going to draw it like that. Remember that bromine can be anywhere. It can be up, down, doesn't matter. Okay, but here you have a completely non-polar area, and every single one of these are going to have these non-polar areas. So here you actually do have a London force, and then over here you have a dipole force. So in my opinion, the correct answer here is B, because you have the London and the dipole. Most of the markers I spoke to said that they are looking for one and that they're only looking for dipole. I strongly disagree. I think this is a higher level 4 question. But it's one of those unfortunate situations where I cannot tell you exactly what the correct answer is. Remember, we don't get these memos until the remarks of these papers are done. But I'm of opinion the answer is 2. You're going to have London forces here, where you have the non-polar part of the molecule, and you're going to have dipole intermolecular forces here between the bromines of the different molecules. All right, I hope that makes sense. I don't agree with the question. It's outside of the scope of the curriculum. But hey, what do I know? All right, then the correct formula for methylbutanone. When you draw this out, but 1, 2, 3, 4, and then I kind of went, but where's the methyl? And I realized, hang on a second, I can't put the methyl on carbon number 1. I can't put the methyl on that last carbon, because then it's no longer butanone, then it becomes pent. So your methyl has to go on one of the middle 2 carbons, which then means if you count here 1, 2, 3, that butanone, that ketone double bond oxygen, cannot go on this carbon. This carbon cannot make 5 bonds. So it has to go on the next carbon. All right. And then, of course, I'm not going to draw them in now, but you would have your hydrogen stuck all over the place. So when I have a look at this thing here, this OH here means that it can't be A, right? So I've eliminated A. If I look at B, this thing here tries to tell me ester, all right? And if you look at this picture, everywhere where I haven't drawn a hydrogen, or where there's just a line, there's supposed to be a hydrogen. There's only one oxygen here, so can't be B. It cannot be C, because that would infer, the CHO at the end, would infer that the oxygen would have to be on a terminal or an outside carbon, right? Which means can't be C, which by process of elimination means it must be B. And if you look at it, what they just did is they wrote the structural formula in the opposite direction they did the condensed structural formula in the opposite direction as I did my structural formula. So there's CH3, there's C with its O, there's C with its H, and that's CH3 group, and then there's the last CH3 group. So 1.2 has to be D. Okay, I think that one was fair. The trick here always is to draw these things out, guys. I don't know about you. I need to have a big formula, the full structure. I know it's a pain with the hydrogens, but when you're just drawing it for yourself, you don't have to add the hydrogens in. All right. Then the last of the organic questions, multiple choice questions, was 1.3. So they say you've got a compound, CH3, and then 5 of these CH2 groups and another CH3. So what I did just in my brain quickly is I went, okay, there's the CH3. Now there's got to be 1, 2, 3, 4, 5 of those CH2 groups. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. And then I've got another CH3 there. All right. So that is what I am starting with. Then if you look here, can you guys see they chopped off? Okay. Now instead of having 1, 2, 3, 4, 5, 6, 7, so heptane, they've chopped 3 of the things off, somewhere in the middle, somewhere at the end, doesn't really matter. And now I've got 1, 2, 3, 4 carbons, right? So I've got CH3, CH, and another CH within that last CH3. Right. So I've taken heptane, I've chopped 1, 2, 3, I've basically chopped that off, right? And now I've got left that thing there, which if I drew it correctly, which I'm pretty sure I did, is butane plus R. So R, as you guys can see, has got 3 carbons attached to it, right? Now you need to be careful with the hydrogens, because as you can see here, they've gone propane, propene, propane, propene, all right? So they've only given you the option of the 3 carbons in this chain. But what they are trying to elicit from you is there a double bond on this compound or not? All right, so what I did is I said, okay, this whole thing here has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16 hydrogens. Right? And this thing has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. Which means that this formula here, R, has got to have 3 carbons, and 16 minus 10 is 6 hydrogens. And if you look at that general formula, you see that it's CnH2n. There's no plus 2 there, which tells you this has to be an alkene. Right, which means it has to be propene. So it cannot be C and it cannot be A. Any reaction where something gets chopped shorter, right, means that it is cracking. And so the only option for 1.3 in my opinion is D. Okay, so that was the organic chemistry multiple choice. Now I'm going to move on to the organic chemistry, the longer form questions. So we're going to go to question 2. And as always, table, all right? I think you guys can be pretty sure that you are going to get a table. And I'm not just talking about now, I'm also talking about the end of the year. I don't want you to be complacent and say you will always get a table. But, you know, I really do think that they're going to make the questions harder, but they're going to try and stick to the layout of the question paper. Okay. Right, so we've got C5H10O. Remember, molecular formulas don't tell us where that oxygen is. If I look at this general formula, it is either an aldehyde or it is a ketone. Sorry guys, I've got puppies, you're going to hear them bark. It is just one of those things. And of course it's got 5 carbons, so this is pentanol or pentanone, one of the two. Ooh, sorry guys. Alright, B is lots of carbons, all single chains, plus iodo, right? And then this 2 here would be an ethyl group. Okay, so that is a haloalkane. Then we've got butanoic acid. We've got this thing here. I was very unsure of how to draw this. This compound D is in a question, so let me just get that over and done with. So the fact that it's got CH3 means that I've got CH3 bonded to a carbon. And let me just make it very clear to you guys. All 3, the CH3s, is bonded to that carbon there. So there's a CH3 group, there's a CH3 group, there's 1, 2, 3 CH3s, and then I've got my OH bonded to that carbon as well. Okay, then here CH2C, this should tell you, the fact that it's CH2 at the edge there, that you're going to have that situation, which means double bond to that carbon. I think they've become more and more mean with this. I would have liked them to actually show that double bond there. And then again, weird things here. On this carbon, you've got a CH3 group and you've got a CH3 group. Like weird, but anyway. Then here, this OO here in the middle, okay? The difference between that and butanoic acid. Butanoic acid, you're going to see at the end COOH, right? Or right in the beginning. You're not going to have COOC. COOC tells you ester, okay? So you're going to have that carbon with its hydrogen, oxygen, carbon, right? That's what you're starting to see there. The trick is going to be to figure out on which of the 2 carbons is the other double bonded oxygen, but the way in which they ask this question actually makes that quite nice. Alright, so we've kind of gone through the compounds given. I like to do that first anyway. Remember, it's your question paper. You are allowed to scribble on your question paper. You could write your name on it and then come fetch it from us afterwards. Like really, please guys, you know, especially since we're still heading towards September and end of the year, don't be shy to make that question paper your own. Highlight things, try and write down what you're thinking when you are answering the question, so that when you go back with your script and you check out what you did right that you didn't expect yourself to do right, or what you did wrong that you were expecting to have correctly, that at least you have your thinking already on your question paper. Alright, so define the term unsaturated carbon. There are many definitions that they could be asking, okay? Unfortunately, organic chemistry is one of those. It's probably about 95% studying, which I know you guys love. Alright, so it is a compound with one or more multiple bonds between carbon atoms in their hydrocarbon chains. The definition that they are looking for is that first part, a compound with one or more multiple bonds between carbon atoms. They will forgive you if you do not write the hydrocarbon chains, all right? But you have to write that first part, and more I get frustrated with the way that they mark it, but it does mean that I can enforce on you that I expect of you to write that definition down as it is given on the information, in your exam guidelines. Please, guys, don't throw away stupid marks for that. I know sometimes in the moment you're stressed, but you know, it really is somewhere where all of you can pull your marks. All right. Then for 2.1, write down, and this is where you have to be very careful. Write down a letter that represents. Okay, please don't go, write down a name or whatever, just the letter. Okay, in grade 12, if you write down anything else that they're asking, they just mark it wrong. Alright, so they said the unsaturated compound. Now, if you had not gone through this process right in the beginning, you might struggle with this a little bit. But because I've gone through it, I've already seen, hang on a second, that CH2 there means that somehow this thing is going to have a double bond there. Okay? Like I said, I drew it out just to be double sure. So firstly, I had my CH2, then my C with CH3 and CH3 attached, and then I put single bonds in between all the carbons, and then I count, I double check, and then I see, but hang on a second, this carbon has got 1, 2, 3, and this carbon also only has 3 bonds, which means that double bond has to be there. So the answer for 2.2.1 is E. Okay. Then 2.2.2, a functional isomer of C. All right. Want to remind you that for functional isomers, you have 2 pairs. You have aldehydes and ketones that are functional isomers of each other, and you have carboxylic acids and esters. All right. Now again, this question does ask a lot of you in terms of thinking, but you only have to write down the letter. So for C, you can go, okay, it's butanoic acid. So I am looking for an ester. And there happens to be the only compound on this board that has 2 oxygens. If you look there, that's got 1 oxygen, right? So for me, this is a relatively simple question. Just don't look too deep in it. I know sometimes you guys want to over answer the question when it seems too easy. All right. So for 2.2.2, the answer is F. All right. For 2.3, name 2 homologous series to which A can belong. All right, guys. So again, this with that single oxygen could also, I think, if you argue it, be a alcohol. But the general formula for an alcohol, Cn plus 2, the general formula for an alcohol ends up being that you could also write it as CnH2n plus 1 OH. That H there, it doesn't really matter. Okay, so that's the general formula for an alcohol. The general formula for an aldehyde or a ketone is CnH2nO. Alright, this is where it is incredibly useful to know your general formulas. There is a page on the Science Clinic notes, if you guys want me to email that to you as well. The Science Clinic notes has got the chemistry. Not all of it's correct, so please just be careful, but it's got a chemistry summary in as well that I think is quite nice. I'm happily email that to you guys as well if you don't have it yet. Okay, so 2.3, name two homologous series would be aldehydes and ketones. Right, now things start getting harder, okay? So now you are not just asked from 2.4 onwards to just regurgitate fact, you are also now, there's quite a lot of tricky things that you need to go into. Alright, so 2.4, is it primary, tertiary, or secondary? And give a reason for your answer. All right. Unfortunately, this will be one of those situations where, although negative marking is not applied, I cannot see how you could, in this situation, not end up with a negative situation. Because when you analyze compound D, if you analyze it incorrectly, your reason's going to be wrong. Okay, so it's just something to just slow down about. That is why I drew D. Okay, that CH3 there confused me quite seriously, which is why I kind of looked and went, well, okay, but I can't attach them to each other. And then I kind of thought, well, let me start with that carbon and then work my way backwards. All right, so tertiary, secondary, primary. And when I first looked at this alcohol, made the mistake of going, oh, but the OH is right at the end, so it has to be primary. Because that is one way in which I often identify a primary alcohol, is that OH is right at the end. But this OH is bonded to that carbon. This carbon is bonded to 1, 2, 3 other carbons. And so this is a tertiary alcohol. All right? So the long explanation, it is tertiary because the hydroxyl group is bonded to a carbon that is bonded to 3 other carbons. The short way of writing bonded to a carbon that is bonded to 3 other carbons would be to say that the hydroxyl group is bonded to a tertiary, shorthand for that, carbon. Okay. Again, there is quite a bit of discourse in terms of are you allowed to do that, but it is in the exam guidelines. The 3-0 is not, but you could have just replaced that with a tertiary. So yeah, I'm sorry, it's not. Again, this is one of those things where I would rather you guys stick to writing out the long way of doing it. All right. 2.5.1, write down the IUPAC name of B. Right. So, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. No matter which way I go about this, it is hexane. Okay? Step 1. Step 2, I have 2 substituents, and again, no matter how I count it, I have an ethyl group and I have an iodine group, iodo. Now the thing comes, where do I count from to get these on their lowest possible numbers? So, if I go 1, 2, then it's 3, 4. If I count from this side, it's 1, 2, 3, 4. If I start at the top, I have exactly the same thing. All right? And 3 plus 4 is 7, and 3 plus 4 is 7. Okay, so I had to really, really deep dive into IUPAC naming. And I think they asked it with the iodo specifically because, again, currently there are 2 opinions about IUPAC. But the official IUPAC says that alkyl groups get preference before halide groups. So my ethyl is going to be on a lower number than my iodo. In this case, if you did it alphabetically and said E is before I in the alphabet, you would have gotten to the same answer. All right. So, which is the other thinking. Like I say, I cannot give you a specific IOPAC document that states one or the other. But, okay, so we're going to go 1, 2, 3 ethyl, 4 iodohexane. I want to just point something out to you guys. There's always a dash before and after a number. There are always commas between numbers. Okay? So, a dash before and a dash after 4. And if there were more than one number for the same substituent, you would put a comma. Okay? Please just be careful of that. I've seen you guys get a little bit complacent with that. So let's just make dead sure. Okay, that was the IOPAC name for compound B. Now for 2.5.2, they asked the positional isomer of compound D. Okay, back to compound D. Right. So, give me a second, guys, to just block this typing out before. There we go. That makes my OCD heart happy. So, I've already shown you guys, this is what compound D looks like. And yes, I know I'm not supposed to put the CH3s like that. I'm supposed to write them out, but this is for me. All right. Now, it's a positional isomer. The question is, write down the write down the IOPAC name. Sorry, guys, let me put the question up. Here we go. Write down the IOPAC name of a positional isomer of compound D. Right. So, there is compound D, and I need to create a positional isomer. That means that I need to take the OH and put it somewhere else. Right? You can, I've double checked, put it on any of the other carbons. Right? And then, of course, one of the hydrogens, whichever hydrogen that you chuck out to put the OH on, will then go here. So I took my OH group and moved it up to the top carbon. There it is. Okay? And this hydrogen that used to be here, placed there. Okay? And so I end up with 1, 2, 3 in my longest chain. I could also go 1, 2, and 3. But I went 1, 2, 3, which is where I get propan. OH is on the first carbon, propan 1-ol, again, dash, dash, before, after. And then I've got to deal with the CH3, which is methyl, and it is attached to carbon number 2. So the IOPAC name for the positional isomer of compound D is 2-methyl-propan 1-ol. Alright. Let's move on to question 2.6. Okay. Ethanol reacts with compound C. Compound C in the table is butanoic acid. And forms a different organic compound, compound Z. Good. Again, I analyzed it first. So I said ethanol reacts with butanoic acid, 1, 2, 3, 4, and forms compound Z. Remember that the OH and the H gets removed by the presence of sulfuric acid, a hydrator, and creates water. And compound Z is that part, the 2 carbons from the ethanol, and the 4 carbons with its double bonded oxygen from the carboxylic acid. Alright, so write down the type of reaction. Guys, this is nothing new. Esterification. Then write down the structural formula of compound Z. Okay, so again, because I did the pre-work in my brain, and I wouldn't have written this down necessarily on my script, but you can just draw a line through it, or you could just scribble it onto your question paper. So we've got its esterification, and I've got my 2 carbons from the ethanol and the 4 carbons from butanoic acid with its associated double bond. Alright, I think that was a pretty easy question. Then, no, empirical formula, man, but that's like so grade 10, yeah, I know. Okay, so write down the empirical formula of compound F and the structural formula of a chain isomer of compound E. Yeah, okay then. So, the first thing I did is I looked at F, and I counted all the carbons, I counted all the hydrogens, I counted all the oxygens. And I got that compound F has 4 carbons, 8 hydrogens, and 2 oxygens. That is its molecular formula. Empirical formula is it is a molecular formula or a chemical formula that shows all the elements in a compound in their simplest ratio. And it's quite obvious in this case to see that the highest common factor there is 2. So I divided 4 by 2, I divided 8 by 2, and I divided 2 by 2, which gives you that empirical formula of C2H4O. Alright, then they ask for a chain isomer of compound E. And again, we've already loosely drawn compound E. Chain isomer means I move a carbon. And for me, the most logical carbon to move was that guy who was in the middle of nowhere. And so I chopped it off and I moved it to the end. Alright, so the double bond stays where it is. It's not a positional isomer. It is a chain isomer. I move the position of a carbon. Alright, so those 2 were not bad. I'm not quite sure why they were right at the end of question 2, but hey, what do I know? Okay, so that was question 2. Then we move on to question 3, which is all about the physical properties of organic stuff. Nope, wrong one. Aha! Here we go. Good. Very typical question 3, in my opinion. Table with boiling points. I think the only thing that makes this question 3 ever so slightly harder is that there are 2 investigations. Go. So, let's read through it. Boiling points of straight chain aldehydes and straight chain carboxylic acids are compared. The table shows the results obtained. So you've got 1 carbon, 2 carbon, 3 carbon, 4 carbon, and then they give you the boiling points of the aldehydes and the boiling points of the carboxylic acids. For this one, you've got to just be careful that you don't compare investigation 1 and investigation 2 to each other. You could compare a row to each other, or you can compare a column to each other. Be careful that you don't get confused. Right. Define the term homologous series. Very, very simple. A series of organic compounds that can be described by the same general formula. Okay. Again, that is as it is in the exam guideline. I know that there is an alternative one, but that one to me makes the most sense. Alright, then the numbering here for this question was bizarre, but anyway. 3.1.2, write down for A, the name of the functional groups of aldehydes, and B, the IUPAC name of the compound with the highest vapor pressure. Alright, so the name of the functional group of an aldehyde is a 4-mol group. Again, guys, that is study work. Then they want to know the name of a compound with the highest vapor pressure. I hope you guys all still remember that vapor pressure is sort of inversely proportional to boiling point. So you are looking for the compound with the lowest boiling point in the table. So minus 19. Okay, it's the only negative. So it is a compound that is an aldehyde with only 1 carbon. That's what makes this question hard. Okay, 1 carbon, aldehyde, methanol. Alright, not hard, just requires your noggin to think. Okay. Now they specifically say for investigation 2. So for 3.1.3, we are only focusing on this column here. Go. Write down a controlled variable. What is the same in the entire column? Well, the obvious answer, it is the same homologous series. But that also means that it's got the same functional group. And if it's got the same functional group, then it's got the same type of intermolecular force. So any of those 3 would be considered the correct answer. Okay? Don't overthink it. The one you see first. Right. Then, B. Describe the trends for 1 mark. So increasing, decreasing, whatever. And then C. Explain your answer, but only for 2 marks. Okay? That one I found a bit like, what do you want? Anyway, so, describe the trends. The boiling points increase as the number of carbon atoms in the compound increase. Okay, now, again, keep in mind, I do not have the memo for this question paper in front of me. I cannot tell you for C where they want the marks. Okay? So I wrote down more because, well, I'd rather write down more and target everything that's getting marks than not. Anyway, so here we go. The first thing I said to them is that carboxylic acids have 2 sites of hydrogen bonding. Okay? Probably not important. As the number of carbon atoms in the compound increases, the molecular mass of the compound increases. That is what I said there, sort of. Okay? I have a feeling that this is not the mark. I think the second part is the mark. As the number of carbon atoms increase, there is an increase in the London forces. Okay? Between the molecules. I'm pretty sure at this point you could get away with saying as the number of carbons in the compound increases, the surface area increases, or the intermolecular forces increase. Okay. The thing that I don't know where the mark goes is is it going for this energy overcome, or is it going for a bigger explanation? My gut feel is that if you say an increase in carbon chain length increases the strength of the intermolecular forces, I have a feeling that's the 1 mark. And I think the second mark goes for requiring more energy to overcome the intermolecular forces. That is my gut feel. All right? Just be careful that you write enough to get the 2 marks. Although with 2 marks, I'm pretty sure they would have alternative memos as well. Then 3.1.4, write down the boiling point of butanol. Butanol. I really don't know why that question is so far down, because 3.1.3 requires quite a lot of thinking and putting together of facts, where writing down the boiling point of butanol, I don't know, like level 2 question, maybe? Anyway, okay. So it is 75 degrees Celsius. Be careful that you guys don't not write down the units. Alright. Then, last one for the physical properties. The vapor pressures of A and B are compared. Okay? Completely separate to what happened at the top. Right. OH, COOH. That is what I saw first. OH, COOH. Alcohol, carboxylic acid. Carboxylic acid, 2 sites of hydrogen bonding. Alcohols, 1 site. Okay? Don't know if this is a fair question, but if we go on the theory only, then a carboxylic acid will have a higher boiling point. And if it has a higher boiling point, then it will have a lower vapor pressure. Okay? When I did this answer, let me put this answer at the bottom. I actually wrote down, just so that I can make sure I don't get the wording wrong. Compound A will have a blah 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 vapor pressure to compound B. Alright? So here at the bottom. The vapor pressure of A is higher than the vapor pressure of B. Why? Because the boiling point of B is higher than the boiling point of A. Alright, don't worry, I've got the page. I will walk it through. Fully explain your answer. Right. I do not expect you to do it in this much detail in a question paper, but I wanted to make very sure that when you guys study, that you would have as much of it as you needed. Again, I'm going to scan the memo that I have, and then I will email it to you. Right. So, I had a look. Compound A is pentan 1-ol. For love of money, I quickly calculated it has a molar mass of 88. Because it is an alcohol, it has 1 site of hydrogen bonding. Then I had a look at compound B. It also has a molar mass of 88. Okay? If they asked you why is this a fair comparison, because they have the same molecular mass. Right. But it has 2 sites of hydrogen bonding. Alright. None of this up here is required. Okay. Explain why. And now you need to realize that where the previous explain why question was for 2 marks, this explain why question is for 3 marks. Okay? Again, I think unfair, because, let me just double check before I lie to you guys. There is no indication in this question of what you need to address. Okay, there's no, by referring to the strength and the type of intermolecular force and the energy required, There's none of that. Okay? So, I thought it would be safe to say that both compound A and B experience hydrogen bonding intermolecular forces. Right? Then I said that B experiences or creates 2 sites of hydrogen bonding, but A only has 1 site of hydrogen bonding. Right. For the mark allocation, I don't think you have to refer to a carboxyl group for B and a hydroxyl group for A. Again, I did it just to be overly cautious. Alright, so I've said B 2 sites, A 1 site. Therefore, the intermolecular forces experienced by compound B is stronger than those experienced by compound A. Now the usual, more energy is required, okay? And because I wrote it down in this way, my last statement, the vapor pressure of A is higher than for B, or the vapor pressure of B is lower, but that's not how they phrased the question. All right. Again, guys, with this, I really want you guys to rather be safe and write down more than enough facts for them to give you marks for. Good. Right. Last of the organic questions was a reaction question. This is not new. We all know that the organic reactions, they often give us a flow diagram. Okay? This is nothing new. Alright. So they say compound P is a primary alcohol. It undergoes elimination. Guys, that should be screaming at you that it's dehydration. And compound Q is therefore an alkene. Okay? Then compound Q, I add water, and the first time I saw this I went, but why? I'll show you why now. This is hydration, and so S would be an alcohol. Yes, I know, let's work in a circle, why don't we? And then alkene, that forms butane and alkane, so this has to be hydrogenation. Okay, all of that very quickly done on my question paper. Right. Now I really like how they've phrased 4.1 and 4.1.1 and 4.1.2. Write down the type of addition reaction represented by II, reaction 2, so that is hydrogenation, and represent the type of elimination reaction represented by reaction 1. Again, I really like how they worded this. It leaves there's no gap for you to be unsure of which answer they want. So elimination of an alcohol is always dehydration. Like there's no other elimination reaction in grade 12 caps. Okay. Write down the IUPAC name of P. And here's the first place where I think you guys start panicking. I want you to look here. Can you see there's no option of cracking? Right? That means that wherever we can see how many carbons is involved in this flow diagram, that's the amount of carbons we grab. And there's one place where they tell us how many carbons. It is here at the bottom with butane. Alright? That means that compound P, 4 carbons. Compound Q, 4 carbons. Compound S, 4 carbons. There's no cracking involved here. Alright? So, this would have to be butanol, primary alcohol. You can draw it out if you want to, but primary alcohols, the OH group is on carbon number 1. Again, dash before, dash after. Alright. So those were the relatively easy questions in my opinion. And then we go down to 4.3, 4.4, and 4.5. Well, 4.5 I found nice again. I'm worried that they hide a question like 4.5 down here at the bottom and you guys don't do it simply because 4.3 and 4.4 are harder. Okay, so again, please do me and yourself a favor and make sure you read through all your questions. Okay, 4.3, consider reaction 3. Reaction 3 is an alkene hydrated to an alcohol, and we're only worried about the major product. Markovnikov's rule. Hydrogens are the life of the body. Right. Write down a balanced equation using condensed structural formula. Okay. The 4 marks did concern me a little bit, but I don't know. Maybe I'm wrong. Okay. So, we had butane 1-ol, and we pulled that ol off, and the double bond got formed here. Okay? So we've got C with 2 H's, and the double bond to our carbon. This carbon, in order to bond that way, can now only have 1 hydrogen on it. Okay? 1, 2, 3, and 4 carbons. But1ene. I hydrate it, so I add water. Nowhere in the question do they state that you have to add reaction conditions. I did because I am worried about that 4th mark. If I look at it, there are 3 things that I am drawing in condensed structural formula. Okay? So I am concerned that the 4th mark here would be going for showing that it is heated and that I use a dilute strong acid catalyst. But anyway, alright. So, the OH and the H from the water has to be added to these 2 carbons here. Okay? Markovnikov's rule says that the hydrogen will go on the carbon that already has more carbons, which is that guy there. Okay. So, there's my carbon with 3 hydrogens. There's the CH that I already had. And I add the OH on there. You could also do it more structural if you wanted to. Alright. Then, there's that CH2 and that CH3 there. Alright. The only reaction you would ever have to balance in terms of real stoichiometric is the one we're going to do for question 4.5. Alright. Then, for 4.3.2, write down the name or formula of a suitable catalyst. Now, the reaction condition states you need a strong dilute acid catalyst. For me, I always remember sulfuric acid. I love it. If you need it to dehydrate, you make it very concentrated. If you don't need it to dehydrate and you need it to break bonds, you make it quite dilute. Okay, but you could have also used phosphoric acid. They're going to look for any strong acid and they're going to look for AQ. Alright, now we move on to 4.4, which I thought was an unfair question, but that's just me. Butane can be converted into compound B in a 2-step reaction. 1, 2. But guess what? That's not what they want. Because you can't go that way with this reaction. You can't go dehydrogenation and hydration, because guess where that's going to end you up with? It's going to end you up on this side. Okay. So we have to follow a different route. We can't eliminate and add. So the only way we can do that is to go substitution, substitution. Okay. Anyway, write down using structural formula balanced equations for these two reactions. Alright, so those of you who are strong in chemistry or want to focus on this, those of you who don't enjoy chemistry and could not be bothered, you probably won't have a go at this. But anyway, okay, so the first thing is that I am going to halogenate, so substitution, butane in the presence of sunlight. Right, this is one of your substitution reactions. There's only 3 of them. And I am going to hope and pray that I can pull a hydrogen off one of the first carbons. Good. Please don't forget that the hydrogen I pull off there, I have to include. Okay. And then my second step would be hydrolysis, where I substitute. This is also substitution. I know. I wrote substitution on the first one because I know halogenation. If you just say halogenation, you guys could also interpret it as a addition reaction. Alright. So then I substitute that chlorine with a hydroxyl group. Alright. And again, I don't know where the marks are going. I have a feeling it's going to go maybe 1, 2, 3, 4, 5. I don't know. I'm going to be honest with you guys. I don't know where they would put these marks. Okay. So not an easy question. Under pressure, I probably would leave it out. But, you know, I do know that there are some of you guys that will want to push for a question like this. Okay. Last one. Easy one. Write down a balanced equation using molecular formula for the complete combustion of butane. So, butane, CH, C4H10, combustion, oxygen, combustion forms carbon dioxide and water, right? 2 ways of approaching this. Let me get a color. Right, so if I was unsure about the balancing, I always, for combustion, follow a process. I balance the carbons first, then I balance the hydrogens, then I go back and balance the oxygens. Alright, so 4 means 4 carbon dioxides. 10 hydrogens, there means 5. And now when I come back becomes the problem, because 4 times 2 is 8 oxygens plus 5 oxygens gives me 13 oxygens. And so, technically speaking, I would want to write the 13 over 2 in front of the oxygen. They don't like 13 over 2, so what I did to get here is I multiplied everything with 2. So that I could get rid of my fraction. Alright guys, so that is the organic chemistry.